Okay, this is section 10.4, slope and rate of change. Here we're going to talk about like the definition of a linear line, what we can read about linear lines, and one in particular thing that linear lines have is something called a slope. So if you look right here at this line, notice it's like increasing at a certain rate. It's going up and it keeps going up. By all the graphs that we've drawn, we've noticed that we've had different graphs that are like, let's say we have a graph that, this is a rough graph. We had one that goes like this, downward. We've had some that go up very slowly. We've worked with ones that go horizontal, and we've also worked with ones that go vertical. All different kinds of lines, and each one has something called a slope with the exception of this one, and we'll get to that later. But the rest of them, for this one, and this one, they have some kind of slope associated with it. Now, when we're talking about slope, we're talking about how fast something is increasing or decreasing. So what I want you to think of when we're talking about a slope is think about a hill or something that you're walking up. I give people the example of a treadmill, right, over at the gym if you've ever been on a treadmill somewhere before. Some of them have like an incline option, and your incline meter says 0 at first, right? So as it's 0 in the very beginning, your incline will have like 0 on it. Once you pop that sucker up to like 2, your treadmill might move up slightly. Pop it up to 5, it might move up slightly more. But what I want you to notice is between these two things, notice there is no change here when your thing was set to 0. Here, there's some kind of change going on. You might have set that to like 2. And this one, you can see there's an even bigger change. This one you probably set to 5. Those are all called slopes. Now, as you can see, as the line increases, like this one, if I draw one like that, maybe I can just call that one, I'm not saying it is, we can call that one like a slope of 10. You can see that it increases more. So the steeper the line is, the higher the slope will be. So that's the case with positive slopes and negative slopes. Positive slopes are something that go from left to right. They go from this direction. You always start out left and go right, left, go right, left, go right. That would be a positive slope. If I wanted to draw some negative slopes, let me go ahead and clear this out. If I wanted to draw some negative slopes, I could have a line that goes downward, even more downward, even more downward. And you can see that each one of these has some kind of decreasing slope, assuming these are like straight lines right here. So from here to here, from here to here, from here to here, you can see from one point to the next, it's going downward, and that would be something called a negative slope. So every straight line has a slope, whether it's increasing or decreasing. And on here, these examples right here are something called negative slopes. So instead of like a positive number, we would say they're negative numbers. Like this might be -2, this might be -5, this one might be -10, because it's going downward from left to right. So from left to right, it's going downward. So that's why it would be a negative slope. You always read these graphs from left to right, left to right, left to right, and that would tell you if it's a positive or negative slope. Now, looking at this example that they have here, they're showing that. You can see that you have a slope going from here to here. Any 2 points, you can measure the slope or the rate at which the line is increasing. So a slope is calculated by any kind of change in y over change in x, meaning there is some kind of vertical change with every horizontal change. So you go up a certain amount of units, you go over a certain amount of units. You go up a certain amount of units, you go to the right a certain amount of units. So your slope is determined by your change in the y movement, which is a vertical change, and your change in the x x movement. That's a horizontal change. So let's go ahead and look at the more broad definition that the book gives. Let's erase that. Let's go to the next page and check it out. So looking at this page, we can see that it gives us a general idea of any kind of vertical movement we have some kind of horizontal movement with it to calculate a slope. This one's a little smaller of a difference because the line's not as steep. Now, everything has a slope. We'll get to example 1 here in a minute on how to calculate, but you can see how this one goes downward. It goes down, then to the right. So we use this general formula right here. And that's our slope of a line formula. And it's one of the many parts of a linear line and how we calculate linear equations. This, it says, the slope is equal to rise over run. Rise means the vertical movement. Run means the horizontal movement. So we can go anywhere from change in y and change in x, and we can find that by calculating the points that will actually give us a slope, an algebraic slope. Remember those numbers they gave you, like 2, 5, 10, -2, -5, -10, all of those. Those are numbers that calculate the slope. So we can go ahead and do this one for example 1. Go ahead and jump over to my page, and I'll try to start working on stuff right here. So example 1 wants us to find the slope. I'm going to paraphrase. Find the slope between two different points, -1, 5, and 2, -3. So it wants us to find the slope between the 2 points. Now remember what I talked about earlier in another lesson was as long as you have 2 points, you can make a straight line, right? These are our 2 different points. Here's our slope formula. M equals y2 minus y1 over x2 minus x1. From now on, M is going to represent your slope. So if you ever see the letter M, it usually means slope when you're talking about graphing and linear equations. You'll see slopes again if you go to like a calculus course or anything, or if you just read any kind of chart from maybe a finance or business course, you'll see a lot of straight lines. You'll see and calculate different slopes like rates of increase, rates of decrease. But M in the algebraic math sense will usually represent slope. So from now on, this will be slope. Now, y2 and y1 and x2 and x1 represent the 2 different points. We can call this one right here is like our point 1. Now, this one would be called our point 2. We usually abbreviate with this right here. The P insinuates that it's a point, and the 1, the little subscript below it means 0.1 and then 0.2. That's what it's saying. So we're saying 2 different points, but they're both points. So how we label it is like this. I want to call 0.1 x1 and y1 because this is the x coordinate and this is the y coordinate for the points. So we call it x of 0.1 and y of 0.1, whereas the other one will be x of 0.2, y of 0.2. And I like to label them all the time because it helps us organize everything, make it a lot easier to read. Now all we have to do is plug in the values. So I have to plug in y2 and y1 for y2 and y1. We're going to be substituting the values in. So let's look at the first one. Y2 is -3. Y1 is 5, so I can put -5. Divided by x2, which is 2. X1 is -1. So be careful with this. We're going to put minus. Remember I told y'all back in the day, whenever we substitute numbers, you want to put in a negative number in parentheses. Because what happens on the bottom, remember this part? The negative times the negative makes a positive. So that becomes 2 plus 1. Then finally, -3 minus 5. Simplify the top and the bottom of the fraction first. -3 minus 5 makes -8. And then that's divided by 2 plus 1. 3. There you have it. M is equal to negative 8 over 3. That's our final answer. So finding the slope, it doesn't always have to be a whole number because we know math isn't always exact numbers. We might have, or exact numbers in the sense of nice whole numbers like 5, 6, 7, 8. We have negative 8 over 3, which is an exact fraction. So this is, right here, our rise over our run. And that's going to be important later when we're starting to graph using the slope. So our rise would be negative 8. Our run would be 3. Makes it a little easier to read. Finding the slope is crucial to finding linear equations, which we'll do later. And finding the slope helps us graph a linear equation much quicker. So let's go to example 2. Try another one. All right, so it says find the slope. And it wants us to find it between negative 1 and negative 2 and 2 comma 4. Looking at these, I'm going to write down, it says find the slope, so I immediately write down my slope equation. And we go ahead and label our points. This is x1, y1, x2, y2. After labeling them, plug them in directly. y2 is 4, y1 is negative 2, so minus negative 2, over x2 is 2, x1 is negative 1, so minus negative 1. Go ahead and evaluate. Remember, negative times a negative makes a positive. This makes a positive as well. We're left with 6 over 3. Now, 6 over 3 can be reduced. So that's a fraction that can be reduced. 6 divided by 3 is going to be 2. There you have it. So your slope is equal to 2. That's all there is to finding slope if you have 2 points. As long as you have 2 points, you can always find the slope. And they have to be 2 different points, of course. 2 different points gives you a slope. So just a summary, whenever we find a positive slope, if m equals a positive number, your line's going to look something like this. It's going to go up from left to right. If your slope is a negative number, like what we got on the previous example, negative 8 over 3, your line's going to go downward from left to right, and that's what I summarized earlier. So what we can do is we can find the slope with the 2 points given, or we can use something of a new equation. One of the equations that we have is something called slope intercept form. This is a general equation for any kind of linear equation. Remember, a linear equation is a straight line. So any kind of graph that has a straight line, doesn't matter. Anything that looks like that, we can find the slope-intercept form of it. So with math, we have a lot of formulas. Slope-intercept form is y equals mx plus b, where y just represents one of your y coordinates. Remember, m is your slope. X is an x coordinate. B is going to be your y-intercept. Hence why it's called slope-intercept form. We have a slope and an intercept. So we're trying to put something into slope-intercept form. Or if we have something in slope-intercept form, we can identify a lot of parts of it. So for example, 3. It says, find the slope and y-intercept of the equation. The equation is going to be y equals 3 over 4x plus 6. So what we do is we use our given equation, and if it's already in this form right here, we can identify certain parts. Oh, look at that. Y equals mx plus b. This one's a 6, not a b. So we can see that, oh, there's our m, there's our b. Our b represents our y-intercept. Remember that y-intercepts are always going to be 0 comma some y value, whatever that value is. So to answer our question here, since it's already in the form and everything matches up already, we can see that our slope is 3 over 4. And our y-intercept, some people will write it down as just a number, 6. But I like to put it as a coordinate point. It'd be 0, 6. So you can see it as a coordinate point. There's your answer. You don't have to do any algebra or anything to solve for this one because it's already solved for you. It's already set up with y equals mx plus b. That makes it a little easier for us to do. So having it in this form helps us find stuff quicker, and it'll actually help us graph quicker too. So let's look at another example. Example 4. I'm going to write example 4 right here. I'm going to write our slope-intercept form, so we can refer to it. Y equals mx plus b. So for example 4, it says, find the slope and the y-intercept of the equation. Our equation is negative y is equal to 5x minus 2. Now currently it kind of looks like it's in the form y equals mx plus b. But notice this y right here isn't by itself yet. It has that negative around it. There's a negative sign around the y. So if we see here, that negative, we got to get rid of that negative first. We have to have y completely by itself. And this is where your section 9.5 stuff comes in, where you have to solve for a variable. We have to solve for y. If I solve for y and get it exactly in this form right here, this will help me identify the slope and the intercept much quicker. So to solve for y, we have to get rid of the negative, so we have to divide by negative 1. But remember, the rule is for division and multiplication, if we divide one side, we have to divide everything on the other side. Negatives cancel out. That gives us y equals 5 divided by negative 1 gives us negative 5x. Negative 2 divided by negative 1 gives us positive 2. So now we can see it's in y equals mx plus b form. Y equals mx plus b. And we see our slope just by looking at the number that's in front of the x, it's negative 5. And then looking at the number for the y-intercept, that's going to be 2. So if it says it, put it as a coordinate point, 0, 2. And there you have it. Just one step to solve for y in this instance. Now, they're not all that easy. You don't just solve for y that quickly for all of them, but some of them are a bit more involved. And that was for example 4. Let's look at example 5. Example 5 is a bit more involved. Again, I'm going to put the slope intercept form up here so we can refer to it. Example 5, again, this one says find slope and y-intercept. This is to find both. Our equation is 3x minus 4y equals 4. Our goal is to get the y by itself. We need that y by itself first. But we have all of this in the way, and we have this negative 4 in the way. So going back to our ideas from 9.5, remember, work outside, then go inward towards the y. So we should get rid of this first, and then we'll get rid of the negative 4. So looking at this, in order to get rid of the 3x, I need to move it out of the way. So that's minus 3x on both sides. This is all your 9.5 stuff. It gives us negative 4y equals, I'm going to write this first, negative 3x plus 4, because I'm already put it in mx plus b format. Makes it a little easier to set it up right away. Put the x in the front. And then your last thing, you got to get rid of the negative 4. divide by -4 on everything. That only gives you y equals, remember, a negative divided by a negative makes a positive, 3 over 4x. 4 divided by -4 is -1. Now it's in the format. Y equals mx plus b. Now, even though this says plus and this says minus, they're still in the same exact form. It's just your y-intercept is going to be different. Your slope is 3 over 4. And your y-intercept, because this is a -1, we'll say our y-intercept is 0, -1. And that's our answer for both. So that one took a few extra steps, but it was just, well, all the other ones were only 1 step. This one was 2 steps. But being comfortable again with your 9.5 stuff is key. Let's look at some special case ones. Let's look at, go ahead and write down the slope-intercept again. Slope-intercept form, going to need this. Y equals mx plus b. Example 6 just wants us to find the slope. Didn't ask for y-intercept, just says find the slope, and the equation is y equals -1. Remember from our earlier lesson, if we had something that said like y equals c, like some kind of number, that makes a special type of line. It'll make a horizontal line. So if we draw it out, I want you to visually look at this and see how it looks. That's going to put like 1, 2, 3, 1, 2, 3. Doesn't need to be perfect. If I wanted to draw y equals -1, remember I go down to -1 on the y-axis, and I go ahead and draw a horizontal line there. So the horizontal line shows the graph and the slope. You can visually see it. But let's think about this. Remember, a slope is calculated if there's a rise over run to a different point, or some kind of rise over run to a different point if it's going downward. This one, from some point to another point, doesn't have any y value. Think about the treadmill again. If the treadmill reads flat, meaning there is no increase or decrease on the treadmill, it's neither going up nor down, that would mean there is no slope. So we don't say there is no slope. We say the slope is equal to 0. That would be your answer, meaning there is a 0 slope going on, but it can change. It can go up to 1, 2, 3. It can go down to -1, -2, -3. But we say slope is 0. Don't say no slope, because sometimes it might be confused with our next example. So if it's a horizontal line, your slope is going to be 0. So let's look at the opposite. What about a vertical line? Example 7 wants us to find slope of x equals 5. So if we draw x equals 5 on a graph, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 3, 4, 5. Remember, if we have something like x equals c, that's going to give us a vertical line. So we're going to go over to 5, 1, 2, 3, 4, 5. On the graph, on the x-axis, because it says x equals 5, and we're going to draw a vertical line. So if it's a vertical line, the vertical line means there's an undefined slope, because rise over run says there has to be some kind of rise and run change. On this one, on the top one, there was no there was a horizontal change, but there was no vertical change. So what happens is on this one, rise over run for this top one, there was 0 rise, but there was some kind of run going on. 0 divided by any number besides 0 would make 0, right? So if this number was 0 divided by 2, it's equal to 0. If it was 0 divided by 5, it's equal to 0. But the 0 will always remain on the top because there is no rise going on. Whereas for a vertical line, there is plenty of rise and run going on. It's moving up and down. So the rise is always going to be some kind of number. Whereas the run, notice there's no horizontal movement. The graph does not move to the left nor the right. So this one has a 0 run. When we divide by 0, you're going to end up getting undefined. So there is no slope that exists for it, or rather the slope is undefined for it. So looking at this one, we would say undefined slope, or you can say it has no slope. Either or is correct. This terminology is correct. The other one, I'll remove that slash. You can either say undefined slope or no slope. They both mean the same thing in this instance. So remember, horizontal lines that say y equals -1, they result in slopes of 0. Vertical lines that say x equals some number result in vertical lines, which make no slope or an undefined slope. So we bring everything back full circle. Let's go back over here. I'm going to show the book. It has a summary of everything for us. All right, it's one other page. The book summarizes all of our slopes together, meaning what's a positive slope, what's a negative slope, and what's a 0 slope, and what's an undefined slope. So one more page. If we look here, any slope that goes upward from left to right will have a positive slope, meaning m is going to be greater than 0, meaning it's going to be a positive number. If it goes down from left to right, we're going to have a negative slope. M is less than 0, so that means we're going to have a negative slope. If you have a horizontal line, the slope is going to be 0. If you have a vertical line, it's going to be an undefined slope or no slope at all. So that kind of summarizes all of our different slopes and what they mean. Now, look at objective D. This one talks about how we can analyze two separate lines together. If we look at this one says parallel and perpendicular lines. Parallel lines are lines that run parallel to each other, meaning they'll never intersect. So if I have any kind of two lines on a graph, let's just draw a quick one really quick. If I have a graph, got the little arrows here. If I draw two separate lines on that graph, let's do purple, I can draw them this way and this way. We're going to assume these two purple lines are parallel. That means they're never going to intersect. But if I change just one of those lines very slightly, like if I leave just one of them the same, let's pretend that's about the same. But if I change the other one just a little bit, you see that the lines will eventually intersect at the end. So what it's saying is, notice these two lines look the same, they're just kind of shifted. If the slopes of two equations, like if you see here and here, if the slopes are the same, if you look here, it says -2 and -2, then the lines are always parallel. We don't care about these two numbers, the 4 and the -3. That doesn't matter. 4 and the -3 will result in just a different y-intercept. So you can see this line right here is actually this line. Oops. Let's go ahead and erase that. I done goofed. There we go. That's this line right here. I'll just point to it because you can see it has a y-intercept of 4. That's what our y-intercept is right there, 4. Whereas the other line, make this red, is this one right here because it has a y-intercept of -3, which is right there. But their slopes are the same. -2, -2. They both go, this one looks like it goes over 1, 2 units, and it goes down 1, 2, 3, 4 units. So it goes down 4 over 2. That reduces to negative 2. This one I could choose any 2 points as well. I can see there's a nice intersection here and then here. This goes down 1, 2, 3, 4, and it goes over 1, 2. Again, down 4 over 2 simplifies to negative 2. So they have the same exact slope. So if they have the same slope, they result in parallel lines. Now, let's look at the next example. We talk about perpendicular lines. These are a little trickier. Perpendicular lines are lines that intersect right here where they intersect. They make something called a 90-degree angle. So when we look at this right here, this intersection, it makes something called a 90-degree angle. We'll draw it with like a little square. If you're taking a geometry class, usually that little symbol means it's 90 degrees. You might have seen this in like a geometry class. That means 90-degree angle. You get rulers or your walls to the floor are usually 90-degree angles. They make a perfect L or a perfect T shape. Perpendicular lines are, we can see that they're perpendicular by analyzing the slopes of the two lines. If I look at the slope here, 4, and the slope there, negative 1 over 4, that tells us that they're perpendicular lines. Essentially, if they have negative reciprocals, that means that they're perpendicular. So for instance, if I look at 4 right there, and this one's negative 1/4, take the number 4, and you're going to make it into a negative number. So we're going to start out with 4. If you make it into a negative number, that makes negative 4. Now remember, the reciprocal means to flip that number. So we go from 4 to negative 4, then we're going to go into the reciprocal, which makes negative 1 over 4. This would be the negative reciprocal of this number. So if I ever wanted to see if two lines are perpendicular, I could check the negative reciprocal. So if we did a couple of examples, let's say we have the number 3. If I wanted to find the negative reciprocal, I have to apply a negative and then do the reciprocal, negative 1 over 3. That would be the negative reciprocal. If I have, let's say, negative 5, well, the negative or the opposite would be 5, then do the reciprocal of 5, which would make 1 over 5. That's your negative reciprocal. If I have, let's say, 2 over 3, because slopes can be in fractions, that would make negative 2 over 3, then do the reciprocal of negative 2 over 3. That would be negative 3 over 2. There it is. To clear them out, give a couple more examples. Let's say we got negative 1 over 4. Well, apply the negative, the opposite, that'd be 1 over 4. Then the reciprocal, which would be 4 over 1, which would make 4. How about 3 over 5? Apply the negative, negative 3 over 5, and flip it, negative 5 over 3. There it is. What if I have the number 1? Well, apply the negative. And if you flip a negative 1 over 1, that just makes negative 1. You'll end up having the same answer because the reciprocal of 1 is 1. So if I did the other one, let's say we start out with negative 1, apply the negative, apply the reciprocal, you end up getting 1. Now to verify if the two slopes are perpendicular, you can just multiply them if you'd like. And if you get an answer of negative 1, that means they are perpendicular. So for instance, let's look at the two examples we have. We have 4 and negative 1 over 4. By analyzing it, we can see that it is that they are perpendicular to each other. But to verify, we can say 4 times negative 1 over 4. If we multiply them, our answer should be negative 1, and that will tell us they're perpendicular. So 4 times negative 1 is negative 4 over 4. Negative 4 over 4 makes negative 1. So that means that they are perpendicular. We'd say oops, I cannot spell. It's P-E-R, perpendicular. I can't even read that anyway, but it's right here, perpendicular. So perpendicular lines, as long as they're negative reciprocals of each other's, or sometimes people say opposite reciprocals, then they are perpendicular, and they will create that little right angle that you see right there. So what we want to do is, let's look at these examples. For example, 8. It wants us to identify if the two items are indeed, or the two lines are perpendicular, parallel, or neither. So let's look at example 8. It wants us to determine if, identify, again paraphrasing, if parallel, perpendicular, or neither. Because essentially, if they don't intersect, they're parallel. If they do intersect, well, let's see if they're perpendicular. If they're not perpendicular, then it's simply neither. So for letter A, it gives us two equations. We're not actually graphing them. We're going to look at the separate ones. -5, -1 over 5x plus 1. I'm going to write the other one off to the side. 2x plus 10y equals 3. What we want to do is we want to try to get it into our nice slope-intercept form. We want to convert the equations into that form because then we can analyze the slopes. This one right here is already done. This one right here, y equals -1/5 x. It's already in y equals mx plus b form. The other one, however, is not. We have to go ahead and get to the y. So let's minus 2x on both sides. Those cancel out. We're left with 10y equals -2x plus 3. Gotta still get the y by itself. Divide by 10. Divide by 10, divide by 10, divided by 10. And that gives us y equals -2 over 10. The largest number that goes into 2 and 10 is 2. So it simplifies to -1 over 5 x plus 3 over 10. That's pretty ugly. Let me fix that up a little bit. 3 over 10. So now we can see that this one is indeed in y equals mx plus b form. So we just need to identify the slopes. The slope on this one is -1 over 5. This one is -1 over 5. So since the slopes are the same, notice -1 over 5, -1 over 5, we would say that they are parallel. Two lines are going to be parallel. So ask for parallel, perpendicular, or neither. And you have to solve for y to figure that out. Let's do example B. Same example 8, but it's B. X plus y equals 3. -x plus y equals 4. Neither of these are solved for y just yet. So on the first one, we have to subtract x on both sides. That gives us y equals -x plus 3. Now y is solved for. On the other one, we have to add x on both sides. That gives us y equals x plus 4. Now look at the slopes. Notice each one is indeed in y equals mx plus b, y equals mx plus b. Notice the numbers in the front are your slopes. So if you don't see the number, then you assume it's 1. So the first one, it's -1. For the other one, it's +1. So since they're not the same number, we know it's not parallel. It's not going to be parallel. So parallel is out of the question. And then we can check to see if they're perpendicular. So are they perpendicular? Well, looking at them, we can say they are because they're negative reciprocals. But remember, to check if they're perpendicular, you can go off to the side and say -1 times 1, multiply the 2. That makes -1. This tells you that they are perpendicular. And that's your answer. So if we go over to example C, it's going to be the same exact question. It's example 8, part C. 3x plus y equals 5. 2x plus 3y equals 6. Got to solve for y. The first one, got to get rid of 3x. Going to subtract 3x on both sides. And that gives us y equals negative 3x plus 5. Then the other one, we have to subtract 2x on both sides first. Once we subtract 2x on both sides, that gives us 3y equals negative 2x plus 6. Then you have to divide by 3 on everything. So divide by 3 on everything. That gives us y equals negative 2 over 3x plus 2. So let's examine the slopes. We can see that they're all in, sorry, I'm going to change all these colors. Y equals mx plus b. Y equals mx plus b. Slope for this one is negative 3. Slope for this one is negative 2 over 3. So they're both clearly not parallel because they're not the same. So we know they're not parallel. Negative 3 is totally different from negative 2 over 3. We can check to see the perpendicular. If you apply the perpendicular rule, the negative reciprocal, you can see if we apply the negative to this number, that would be 3, then do the reciprocal would be 1 over 3. And that's not perpendicular. Remember, the other way to tell, though, is to multiply them. We can check. Negative 3 times negative 2 over 3. Negative 3 times negative 2 makes positive 6 over 3. And that makes positive 2. Remember, to see if they're perpendicular, it has to equal negative 1. So this would be not perpendicular. So since they're not parallel, we know they're not parallel, and they're not perpendicular, that means the answer to this question would be neither. They're neither parallel nor perpendicular. And that gives us the answer to the question. So looking at this, we can tell a lot about lines, like seeing if something's perpendicular. It helps us with a lot of things in math when you get into some physics concepts. And parallel lines help us finding different slopes of different lines. If we want to have the same slope, well, we have to find a parallel equation to that. So there are a lot of practical examples for this. Now, one practical example we can go over is example 9 in the book. Let me pull it up right here so you can see the diagram. All right. Maybe this next one, example 9. Example 9. Notice that it gives us this little diagram right here. It's saying the grade of the road. So this truck is going downward. And we can calculate something called a grade of a road. You might see like a grade symbol on the highway when you're driving around. There might be like a little truck. It'll show the profile of a truck and it'll show a hill. I think the sign usually looks something like this. It's got like a little hill, and it'll show like a little truck going down the hill. I'm terrible at drawing. And they might have like a percentage written somewhere, like 6% or, 3% grade. I don't know what the threshold is for them to have to write, the percentage down. But we look at this because whenever you're hauling cargo for trucks, this big old truck, it's going to probably have to slow down going downhill, right? Let go of the accelerator, get ready to apply brakes if necessary, because that truck's going to be rolling fast. You got to think about the cargo in the back, right? All the cargo in the back right there, all the good stuff we buy. That stuff, if it's not secured correctly or not secured enough, it might all slide towards the front of the car, right? The front of the 18-wheeler. Depends how heavy it is, what everything's made of, a bunch of different things. But then the other way can happen, right? What if the truck's going uphill? What if the truck's going the other direction instead? If there was a truck driving this direction, well, then it'd be going uphill. So it probably needs to apply more acceleration. It needs to get ready for that, maybe build up momentum before going up the hill to make it easier on the engine. Also, product would then be sliding to the back of the truck, right? If you're going uphill, stuff slides back behind you. A lot of different things. So truckers or even people just driving a car, take your foot off the accelerator when driving down a hill, right? Just coast a little bit. Don't give your engine so much work, or prep for the next hill. Use that as a method of accelerating to go up the next hill. But anyway, I digress. We can figure out some information with this. So this example right here, example 9, tells us at one part of the road to the summit of Pikes Peak, the road rises at a rate of 15 vertical feet for a horizontal distance of 250 feet. So you can see on this, they said rise is 15, the run is 250. They already wrote a rise of a run. If you have a rise and a run, you can figure out the slope. What they did is they took this diagram up here, and they just took the road part, right? You see the road? It says 7 feet vertical, 100 feet horizontal. They found they could just make a slope off of that. So for this one, they did this 15 feet up, 250 feet across. With these two numbers, we can calculate the slope, which is this part of the triangle going up or down, depending on which way you're driving. So instead of saying like a positive or a negative slope, you can't tell truckers going up the hill, hey, this is a positive slope, and then truckers going down the hill, hey, this is a negative slope. They already know that. So instead, we calculate a grade that calculates for both directions. So the grade, to calculate that, take the 15, the rise, divided by the horizontal 250. You'll get 0.06. Now we went over percentages. Remember, to calculate something to a percentage, you have to multiply it by 100. So 0.06 times 100% makes 6%. That means the grade of that road is 6%. Now, I'm no trucker, nor do I know about much in cargo. From my retail life about taking stuff out of a truck. Don't know much about putting it in the truck and driving it on the road. I mean, you can see how this might be useful for you and other people around you. You're going up a hill, you're behind a truck. He's probably going to go a little slower if you have a car, because it's going to take him a while to get up there, so bear with him. Whereas if it's coming downhill and you're going uphill, just, watch how that truck is speeding by. Pretty quick. And a lot of different examples you can find out with it. Example 10 shows you can figure out how much, like the rate of increase, if you have a linear increase for something, like these two dates, they end up saying, oh, it increases by $25 billion for every 1 year. You can find a rate. That's a rate. Some kind of mark over a mark. $25 billion. If we wrote that like as a rate, it would be how many dollars per year. This is considered a rate. You can figure things out like another rate, like miles per hour. You drive. Miles per hour would be a rate. That's something else. We can also say like dollars per hour if you're talking about like how much you make. Well, if you calculate dollars per hour, that's a linear representation. If you make something like $10 an hour, that's supposed to be $10 per hour. If you make $10 per hour, well, that's a rate. So if you work for 1 hour, you make $10. If you work for 2 hours, you make $20. If you work for 3 hours, you make $30. So it's a constant rate. It doesn't change. Your rate stays the same. Hence, the line always goes straight up and down. There is no like curvature or anything. All right. Well, that brings us to the end of 10.4. Pretty lengthy section and very, very detailed. Might take a while to get some of this stuff down. But you need to have the slope stuff down in order to do graphing with the slope. And that'll bring us into 10.5 when we talk about equations of lines. We're going to use that slope idea to graph equations really quickly. Then we're also going to use finding the slope and the y-intercepts of different points to find equations of lines. And it gets a little tricky. There's a lot of algebra going on. So Be sure to have this down for 10.5. And after getting through the homework for this 10.4, go on 10.5.